In this video, we're going to look into a new model from OpenAI, OpenAI O1. Currently, it's available in ChatGPT on this menu over here. If you have the Plus subscription, then you should be able to access it right now. Now, why is it interesting? So the main idea behind this model is that now this model can reason. Before, models like GPT-4 and GPT-4 Mini couldn't really answer you factually every single time. It hallucinates most of the time, but this is an antidote to that. So this video will broken down into three main sections. We're going to talk about what it is and why it's so special. We're going to talk about some metrics, some research. I'm going to go through this specific paper called OpenAI System Card, which is a report/paper that they provided. Talk about how they trained the model and their thought process behind building this model. We're going to talk about some limitations of the model as well, and some also various metrics. By the way, I make similar videos like these on LLMs, machine learning, and other data science tools. So please feel free to subscribe. Now let's see the model in action on how we can actually make a video game.
And the coding prompt is to write the code for a very simple video game called Squirrel Finder. And the reason O1 Preview is better at doing prompts like this is when it wants to write a piece of code, it thinks before giving the final answer. So it can use the thinking process to plan out the structure of the code, make sure it fits the constraints. So let's try pasting this in. And to give a brief overview of the prompt, the game Squirrel Finder basically has a koala that you can move using the arrow keys. Strawberries spawn every second and they bounce around, and you want to avoid the strawberries. After 3 seconds, a squirrel icon comes up and you want to find the squirrel to win. And there are a few other instructions like putting OpenAI in the game screen and displaying instructions before the game starts, etc. So first you can see that the model thought for 21 seconds before giving the final answer. And you can see that during its thinking process, it is gathering details on the game's layout, mapping out the instructions, setting up the screen, etc. And so here's the code that it gave, and I will paste it into a window and we'll see if it works. So you see there's instructions, and let's try to play the game. Oh, the squirrel came very quickly, but oops, this time I was hit by a strawberry. Let's try again. You can see that the strawberries are appearing, and let's see if I can win by finding the squirrel. Looks like I won.
Now, before I dive inside of the nitty-gritty of the training procedures and many other information, let's actually look into some practical stuff. How can you guys actually use it right now? So they tested on 3 different benchmarks. One is completion math, completion code, and PhD level science questions. And of course, it's blowing past all the other previous models, like GPT-4, by a massive margin. Not only that, it is probably the first time I'm seeing a model surpassing human expert. Now, what about inference cost? So from their side, their inference cost has been extremely high for these type of models. Now, because the GPT model so far has matured so much that they were able to kind of take down the cost as much as possible. But when it comes to these O models, they're actually seeming to be quite expensive for the OpenAI. Now, I'm not exactly sure where this guy actually found this chart over here, but it kind of makes sense to me. But again, I'm not sure. Take it with a pinch of salt, obviously. Now, how about usage? Can you guys actually use this model right now? And yes and no. Yes, if you are a company that has been using OpenAI for a decent amount of time, spent a shit tons of money, you should be able to use it right now. However, if you are someone like me who wants to experiment with, train it with, play around with it, you may not be able to use this model right now because you're not in their tier list at the moment. Right now, I'm at the tier 1 or tier 2 maybe. So currently, I don't have access to this type of models right now. However, if you are on the tier 5, you should be able to call the O1 Preview and O1 Mini from your API. Of course, they have some limitations for these models right now, but you should still be able to use it. Nevertheless, probably not be able to productionize it currently, but there you have it. Now, here is a nice summary provided by this, I don't know if it's a person, of some things that they announced this time. So O1 Preview announcement, talk about safety, target audience, overview, market capabilities. And when you go through the OpenAI's website, they are actually approaching this model for people who are researching coding and science-based problems. And then they also have some limitations and other problems with what they have showed so far. So let's get into it. So their focus with this model was primarily focused on reasoning. So what does reasoning actually mean? This is what the OpenAI engineers had to say.
I think related to that, so when we think about like training a model for reasoning, one thing that immediately jumps to mind is you could have humans write out their thought process and train on that. One aha moment for me was like when we saw that if you train the model using RL to generate and hone its own chain of thoughts, it can do even better than having humans write chains of thought for it. And that was an aha moment that you could really scale this and explore models reasoning that way.
For a lot of the time that I've been here, we've been trying to make the models better at solving math problems, as an example, and we've put a lot of work into this, and we've come up with a lot of different methods, but one thing that I kept, like every time I would read these outputs from the models, I'd always be so frustrated that the model just would never seem to question what was wrong or when it was making mistakes or things like that. But one of these early O1 models, when we trained it and we actually started talking to it, we started asking it these questions and it was scoring higher on these math tests we were giving it, we could look at how it was reasoning and you could just see that it started to question itself and have really interesting reflection. And that was a moment for me where I was like, wow, like we've uncovered something different. This is going to be something new. And it was just like one of these coming together moments that was really powerful.
Now, let's look at some metrics over here. So learning to reason with LLMs, here they tested the model on primarily two different benchmarks. First, they look into competitive programming questions. Another one is testing the model on US qualifier for USA Math Olympiad, or AIME for short. And what they saw was while they were training on this graph over here, they can see the accuracy going or increasing over time the more they train the model. Now, when it comes to evaluation, as I mentioned before, it is probably the first time that I am seeing or I'm observing that a model like this has surpassed human level experts, which is absolutely bonkers. Now, here is another set of metrics showcasing the O1 model in various benchmarks. Now, let's get into the chain of thought. I want this video to kind of focus really on chain of thought and their progress on it. So the main idea is that they want to see how the model gives an answer based upon a step of thinking while giving an answer. So for example, usually you would ask something like a question like this, and it would just promptly give out an answer very, very quickly. There is no thinking. It's just whatever knowledge it has parametrically, it just gives out an answer, or sometimes even from websites. However, the chain of thought is more like, hey, you have this prompt over here. It kind of breaks down step by step on parts of the prompt, breaks it down, and then gives you a final answer. And the similar story kind of happens when doing coding problems as well. So here it asks a question about bash, and it just promptly gives it an answer, and at the end, the script fails. On the other hand, it kind of takes the prompt over here, the question, breaks it down step by step, makes various observations, and then gives you a final answer. Now, talking about the paper over here, OpenAI System Card, this is a paper that they released where they talked about this model and how they trained. So their main idea about this paper was kind of giving a light to the area of chain of thought and how it can be used to train a model. And they use reinforcement learning to train the model using chain of thought. However, I was a bit thirsty for more information from this passage over here because they haven't really provided that much information about the model itself, the architecture behind it. Neither did they talk about how they trained the model, what kind of loss function did they use. Was there a new type of training technique that they applied over here? I believe there's a lot of information that they kind of held back, and I understand why, but still, a bit of transparency could have gone a long way. Because at this point, because the model works so well, I'm quite unsure if it's still using transformers at this point. But they talked about various data filtering, proprietary data, and various other things. Now, if we go at the end of the paper over here, we can start to look into some more information about chain of thought. So if you guys were unaware or may not remember what chain of thought is, or actually I forgot what chain of thought was, but essentially the O1 models are designed to generate a chain of thought before arriving at an answer. This is different from the earlier models like GPT-4. This process involves model thinking aloud and refining its reasoning before producing a final output. And there's a couple of benefits to that. First is enhanced reasoning abilities. The model now has better reasoning capabilities. And also, it can more adhere to safety guidelines than before, while also having better explainability, because explainability has been a big problem inside of the AI and LLM space for as far as I can remember. And this kind of gives a much better understanding of what the model or how the model is deriving to an answer. So if someone is just looking for an answer, they can see or trace how the model got modified and changed while he was answering. And that could be very useful for someone or anyone. Now, they have actually tested this COT deception monitoring where they wanted to see when the model was doing this reasoning, was it actually overconfident when answering? So let's say it was reasoning about a specific recipe. If the model didn't know an answer, was it still recommending an answer which is not really supposed to? And so far, they've only answered 0.02% of the time, which is extremely, extremely little. This is what they're defining as the overconfident metric. This is a quite of a very, very new metric that I know of, at least in this area. So essentially 99.8% of the time, it doesn't give an answer to a user when it is not certain throughout its chain of thought, which means the answers now are much more reliable. However, currently, we don't really have access to internet. So the O1 models are not able to browse to the internet, give you guys an answer. It cannot use folders, uploads, or any fancy Excel sheet to give you a complex reasoned answer currently. And it also has various safety guidelines in jailbreaking guard in place. So jailbreaking may not be as easy as it was previously. Alright guys, so this is a quick video on OpenAI's O1 models, a new series of models that is much more capable for reasoning. I hope you found this video insightful. If you guys did, please feel free to subscribe. I make similar videos like these. Alright guys, have a nice day.